In this video, we'll discuss different line segments in circles. So first we'll start with the definition of a circle. A circle is the locus, and locus just means set of all points that meet a certain criteria, in a plane, equidistant, so equal distance from a given point called the center of the circle. Segments that intersect a circle have special names. So a circle, right, all these points on the circle are all the same distance from the center, which is our radius. It's always going to be the same distance from the center. And if we want to name a circle, we can say circle C, or we can use this symbol here, a little circle with a dot in the middle, and then the point that is the center of the circle. So let's take a look at the different segments in a circle. The radius, or radii is plural, is a segment with endpoints at the center and on the circle. So at the center and on the circle here, our radius is going to be CF, or it could also be center and on the circle, CE or CD. A chord is a segment with both endpoints on the circle. So A and B are both on the circle, D and E are both on the circle, so those segments are going to be called chords. Now, a diameter is a special type of chord because it passes through the center, so it has endpoints on the circle and it passes through the center. And it's made up of collinear, so on the same line, radii. So if the radius CE and the radius CD. And that's going to be called the diameter. So diameter passes through the center and is made up of collinear radii. All right, so let's take a look at a couple of questions. The first one says, name the circle and identify a radius. So the circle, we could either write circle P, or we can use our symbol circle with a dot inside, P. And then our radius, so there's 3 different radii. We could pick either one, PN, PM, or PL. But it just says pick one radius, so we can say PM is a radius. Next one, B, says identify a chord and a diameter of the circle. So we can see here, so remember a chord has endpoints that are on the circle, so J and K, or H and G. So JK or HG would both be a chord. So chord, JK or HG. And then we want to know the diameter. So diameter is a chord that goes through the center of the circle. So HG is both a chord and it's also, more specifically, the diameter. So by definition, the distance from the center of a circle to any point on the circle is always the same. Therefore, all radii of a circle are congruent, or equal to each other. Since the diameter is composed of 2 radii, all diameters are also congruent or equal to each other. So if the circle has a radius r and diameter d, the following relationships are true. So our radius is 1/2 the diameter, or d over 2, and our diameter is 2 radii. So remember, if we're looking at the circle, right, our diameter has collinear radii, so we have radius and radius. So diameter is 2r. So if QV is 8 inches, what is the diameter of Q? So QV goes from the center of the circle, Q, to a point on the circle, so that's our radius. So if our radius is 8, remember our diameter equals 2r, so we can substitute in 8 for our radius. Diameter equals 2 times 8, and 2 times 8 gives us 16. So 16 is going to be our diameter. All right, so now, as with other figures, pairs of circles can be congruent, they can be similar, and they can have other special relationships to each other. So let's look at different types of circle pairs. So if two circles have congruent radii, then they are going to be congruent to each other. And it says if and only if. So they must have equal radii in order to be congruent with each other. And if they are congruent to each other, we can say that they have equal radii. So in this example, our r for each, if these two circles are congruent, are going to be equal to each other. The next relationship tells us that all circles are similar. So remember, similar means the same shape, but not necessarily the same size. So even though circles may be different size, every single circle is going to be the same shape. So we can say any circle is similar to any other circle. Concentric circles are coplanar circles, so circles in the same two-dimensional space that have the same center. So you can see here we have two different circles, both with our center at A. And they're going to have two different radius. AB is the radius of the smaller circle, and AC is the radius of the larger circle. Next, we can say that two circles can intersect in two different ways, so that it can either intersect at 2 points, right here, right here, right here, right here. They can intersect at 1 point in a couple different ways, or if they're concentric, or if they don't intersect at all, like this, they would have no points of intersection. The segment connecting the centers of the two intersecting circles contains the radii of the two circles. So we'll keep that in mind as we work through example problems. This tells us the diameter of S is 30 units. The diameter of R is 20 units. ds equals 9. Find CD. So let's go ahead and label what we have here. So we have diameter of S is 30 units. So if our diameter of S is 30 units, our equation for diameter is 2 times r. So we can substitute 30 for our diameter. We know it's 30 equals 2 times r. Divide by 2 on both sides, and we can get the r equals 15. So now we have the radius of our circle S is going to be 15. So if we want to find this part right here, and we know what this CS, our SC, our radius is 15, and now our part that we want to get is just CD. And it also tells us that DS, so this part right here, is equal to 9. So we can see here, 15, the whole thing, is equal to 9 plus whatever CD is, the part that's missing. So if we want to solve for CD, we just subtract by 9 on both sides, so we get CD equals 6. So this part here, and we can double check, right? When we put it back here, if we say CD equals 6, then that makes sense. 6 plus 9, so this part and this part are going to equal the total, 15. So we have CD equals 6.